All right, I'll kick off. There's still a few people dribbling in at the moment, but I'll try and get this through in about an hour's time. This is part 2 to the Airworthiness webinars. This one's covering dingles and defects. We'll cover things over the last roughly 12 months. The last time I did this was, I think, November last year. So there's a little bit to cover. The audience is currently muted. I'll try something a little bit different this time. If you put your hand up during the webinar to ask a question or offer further information, I'll unmute you. I'll see how that works tonight. The information I have is all from SAW reports and defect reports. Some of the information is a little bit limited. So if you have further information to share, please let me know. Just be aware that this is being recorded and will be put on YouTube later on. So just watch the P's and Q's and don't say anything too controversial. So I'll make mention of a couple of last minute items that have happened in the last week. I will talk about some airworthiness aspects of recent incidents. I will talk about some recent defect reports, recent being in the last 12 months. I've tried to group things together a bit so they have something in common. Sometimes that's by type, and I'm not targeting a particular individual aircraft or a particular type. It's just the way that it's been reported. Just remember that some clubs have a very good reporting culture and some other clubs don't, and so you tend to get a little bit of a lopsided perspective out of some of these reports. And as always, this is all about prevention of accidents and incidents. It's not about apportioning blame or liability, so please keep that in mind as we work our way through, particularly if you do end up with a microphone turned on. So the first top press item, powered maintenance releases. We're running down on the last of the old batch at the moment. The new version is being printed this week. The part 3 area, which is where you record your hours on landings, has changed. The blue pages will no longer be present. The engine and propeller hours are now integral with the aircraft hours. So instead of having 2 columns of aircraft hours as per an unpowered maintenance release, you'll have everything on a single page: aircraft hours, aircraft landings, engine data, prop data, as you work your way through. Now we've got around 25 or so of the old maintenance releases left. They'll probably sell out by December and the new ones will start coming out into the system. I'm sure it'll cause a little bit of a problem where people start wondering where the blue pages went. A further update last week on electric sailplanes. There's a total orders of 8 AS34MEs. There's orders for 8 JS3 reses. So the electric revolution is well and truly underway at the moment, and airworthiness needs to keep up with the appropriate ratings and training. If you are involved with providing training for maintenance on electric vehicles, I'd really like to hear from you, or if you have someone in that area, I'd be very pleased to have a chat with you. Also, if you know of any organisation that is able to repack electric vehicle batteries, I'd be interested to hear about them as well. And as of late this morning, had a very good meeting with CASA about weight and balance, and I'm reasonably hopeful that we'll have a weight and balance authority sorted by mid-November. The meeting went extremely well, and there's only a few items that we need to change and get through for their approval. So hopefully that will be done by the end of the year. So on to incidents and defects. What I'm calling an incident at the moment is something that's happened during the operation of the aeroplane, so during flight predominantly. And defects I've labelled as events that have been found during maintenance or on the ground. The First off, undercarriages. A Standler bell late last year, a wheels up landing after retracting the wheel during pre-landing checks. Sounds like the entire flight had been done with the wheel down and put the wheel up on the first check. It was a post-annual inspection evaluation flight, and the pilot was troubleshooting a possible test flight problem. So I was a bit distracted and rushed the circuit and checks. Distraction on these kinds of flights is a common phenomenon, and there's a much higher risk during these post-annual inspection flights of having something that's not quite right and then having to deal with it on the flight. Something similar in LS7, early August this year, again a post-annual inspection evaluation flight. The pilot was unable to lock the undercarriage down. After several attempts, the aircraft landed with the wheel down but not locked, and the gear collapsed and damaged the undercarriage doors. As it turned out, the undercarriage had been deliberately adjusted to have more over-centre to prevent gear collapses. This greatly increases the pilot force, and it was found that sometimes two hands were needed to lock the undercarriage down. There was no placard in the cockpit and no note in the maintenance release to notify pilots that this had been changed. I can see where this has come from. This is a little bit silly that they've increased the over-centre to the point where it's now physically difficult for a pilot to lock the undercarriage down. CS22 has some fairly stringent limits on the pilot forces to be applied to the controls. So if it's two hands, it's well outside the limits of CS22, and so therefore well outside of the certification limits. And you've got much greater risk of overstressing a component in the undercarriage circuit, and a risk of deforming of bolt holes in the push rods, etc., etc., etc. So that needed to be backed off quite a bit, I suspect. Still on undercarriages, an Asta CS, May this year, a winch launch followed by some ridge soaring, and on circuit the undercarriage handle could not be moved, resulted in a wheels up landing. The mudguard on the undercarriage was caught on the edge of a lap joint on the inside of the wheel box. Apparently this is a common phenomenon with the Asta CSs, or the single Astas. If the pilot's a bit enthusiastic in putting the wheel up, the wheel moves a bit too far on the retraction, and the mudguard can catch. I understand that many Asta CSs have had the mudguard removed. It's not the first time it's happened, and I think on this particular aircraft they've gone and put a bit of a fairing or extended the lap joint of the wheel box to prevent the mudguard from catching in the future. One of those events listed there of the previous event was the same aeroplane, so it's happened before on this aeroplane. A Discus, early August, attempted to lower the undercarriage for landing and encountered a restriction. The pilot made several attempts to get it down. Engaged in a few manoeuvres on downwind to try and shake it down. During all this, the pilot got a bit flustered and confused and ended up with the wheel up and thought it was down. Fortunately, landed safely as the wheels up. The undercarriage was lowered once the aircraft was on the ground, and there was no problem found. So don't know whether there was a FOD in the circuit or just something in the cockpit blocking the movement of the undercarriage. A Pawnee. Now, Pawnees really aren't a GFA problem. However, since many of the same people are involved in operating the Pawnee as they are with gliding airworthiness, it's worth mentioning. Whilst taxiing to the launch point, the port main wheel ran through a depression on the runway, or the taxiway, and the tug continued a further couple of metres before there was a thud and the tug lurched to the left. Did not result in a prop strike and did not result in a wingtip strike, but the bungee suspension had failed. There was a hydraulic fluid leaking out of the oleo, and this had deteriorated the rubber. I would have thought that the hydraulic fluid would have been possibly a little bit obvious and maybe left a few stains on the hangar floor in the process, but anyway. ASG 32MI early June. This is a brand new aeroplane. The trainee involved was doing the conversion training. There was a firm landing by the student, and the tail wheel steering response was found to be poor after that landing. On the post-flight walk around, they found that the tail wheel was partially retracted. The aircraft does have a retractable tail wheel. On the two previous flights, the aircraft had been nosing over onto the nose wheel. They were using it as a self-launcher, so the thrust line is very high up, and if you've got two mature build pilots in the front and rear seat, then it tends to tip over onto the nose a bit, and then during the takeoff it tends to rock back onto the tail wheel. The second of those flights was an aborted takeoff due to a possible runway incursion. This resulted in quite a firm thump on the tail wheel. The image there is part of the tail wheel assembly. You can see it's fractured the bracket very badly, and just under the bracket, let's see if I can do some, whoops, go back, get the menu up. You can see in that area there's some deformation of what looks like a cable pull for the retraction mechanism. So obviously quite a strong thump on the undercarriage. I wouldn't mind betting that you'll end up with a redesign of that component in the future, replacement perhaps. Yeah, put the doodle in there. Moving on to engines, ASK 21MI late last year, during takeoff went as normal full power after about 50 seconds, about 400 feet. Pilot 1 heard a noise from the engine. Pilot 2 didn't notice anything. The takeoff continued for a further 10 seconds and the power was reduced to climb continuous power. And at that point, the engine began to lose power and then failed completely. The aircraft had a successful modified circuit. The engine was retracted and the aircraft landed safely. The engine was found to be seized. I don't have any further information on what caused the seizure on that engine. Early this year, February, we had the propeller departure. There was an entire webinar devoted to that. If you go to YouTube and type in Gliding Australia into the search bar, you'll find the Gliding Australia channel and the video of that will be there. The incident report is on the Gliding Australia website in the documents section. If you go to documents, airworthiness, and then AW investigation, you'll see the folder for that particular event and documentation there. Structure, a light sports aircraft motor glider, very late last year, suspected tail flutter. This is primary mode fin flutter, which is probably resulting from damage, mishandled crosswind landing. There's again a separate webinar on that early last year on the Gliding Australia channel. It's well worth having a search on YouTube for some videos by an English gentleman called Gordon MacDonald. That's MAC Donald. The video on hidden fin damage on Nimbus 3, the 24 Asta, is particularly relevant to this kind of event. He's also got a video of discussing how to find fin damage in a stand label from a heavy landing or a ground wreck. They're worth watching, and probably worth incorporating some of those ideas into the post-ground loop, post-hard landing inspections on sailplanes, and but even potentially during a Form 2. Onto controls. Aventus B, August this year, during the flight, the pilot used the flap lever and found that the flap handle bent slightly backwards at the top of the handle. The pilot thought that the grip had come loose. When they pushed it forwards, it came completely off in their hand and had completely torn out of the mount there, as you can see on the photo. The extent of the cracking to enable that to happen was probably visible during the previous form too. That damage had probably been there a while, was just progressively growing, and it's probably visible to the naked eye without needing a magnifying glass or dye penetrant. This one, extremely recent, it's only 2 weeks old. It's still under investigation, so this is based on preliminary information only. This all may change as more facts come to light and as we continue with the investigation. But it's a Nimbus 3T, Friday 30th of September. After launch, the pilot thermal to a little over 5,000 feet, extended the turbo and ran the engine for around 40 seconds. This is the standard procedure that the pilot does typically, like to make sure that everything's working prior to setting off. The engine shut down, but would then not retract, and the propeller was left windmilling in the breeze. Several attempts were made to cycle the retraction system to get it to go down, including an attempt to reach under the instrument panel to jiggle the wires in the hope of making a connection. And then the pilot, to no effect, the pilot reduced the speed to stall, but the prop was still windmilling. Shortly after the stall recovery, with the speed increasing to 60 knots, the sailplane departed to the left in what was perceived as a spiral dive, with increasing speed despite having control input. With some backstick, that spiral dive appeared to develop into a spin. Several attempts were made with the spin recovery controls, but nothing happened. The pilot made the decision to bail out. When the canopy was jettisoned, the aircraft pitched inverted, and the pilots released the straps and fell free of the aeroplane. And I can see there's some comments there from Drew amending some of the details even as I talk. The sailplane was allegedly de-rigged a few days before, had been re-rigged, but an independent check of the controls not carried out. The next flight on the 28th of September, the pilot considered left turns felt abnormal. This is from the pilot's original words in the SAW report. I've heard a different version subsequent to that the pilot had done a lot of thermaling to the right and then had the leans and was struggling with the coordination between thermaling to the left. During recovery of the wreckage, the left aileron pushrod hotelier connector at the outer wing junction with the inner wing was found to be disconnected, and the safety pin, which is the Schempp Hirth locking spring clip, as mandated by AD 418, was missing. I'm not sure how much of a search was made to find it. And subsequent to that, the lever arm in the port aileron circuit in the outer wing was found to be fractured. After the wreckage was removed, they were able to power up the retraction motor outside of the aeroplane, and it was shown to be working. So this is part of the investigation at the moment. The lever arm and the broken parts here are being sent to me by mail. I'm expecting them in a couple of days, and I will attempt to do a bit of macro and micro photography of the fracture face here and see if we can get some clues as to what's going on. The left-hand side image has been reversed. It was a picture from the maintenance manual, I suspect, of the right-hand wing. I've flipped it over just to show the position on the left-hand outer wing. The fracture occurred just forward of the pivot point. There does appear to be some existing crack-like features on the upper surface. I have seen some previous photos which have had some interesting lighting which showed a few different features, but what you can see there may just be a trick of the light and the shadows. Don't know yet. I'll do a better job when it arrives. So at the moment, again, previous comments apply. This is still ongoing, and this is all very preliminary. Hypothesis number 1, the engine retraction failed due to a wiring disconnect somewhere between the retraction motor and the cockpit panel. That's going to be really difficult to verify, as the instrument panel was badly damaged on the ground impact. Remember, impacted inverted. Hypothesis number 2, the port aileron hotelier connection between the outer and inner wing was not safetied and became disconnected during the stall. Again, very difficult to prove or disprove. There's a couple of other possibilities in there, but I'll leave it at that for the moment. Hypothesis number 3, the loss of pitch and yaw control after the stall was due to the dirty airflow, disrupted airflow from the windmilling prop over the elevator and rudder, and reducing the control effectiveness, and potentially reducing the effectiveness of those controls and the ability to recover from the spin. Hypothesis number 4, the port aileron lever in the previous photos had an existing crack and broke under positive G-force during the recovery from the spiral dive into the spin. If you're in a spiral dive with the airspeed increasing, you do need to load the G up to achieve a bit of a high-speed stall to get the aircraft into a spin. So I'm suspecting that the G load was quite reasonable during that event, and that if there was a crack along the upper face, the most likely direction that it broke was downwards. The crack does not appear to be growing left to right or right to left. If there was a bending moment from left to right or right to left, that lever arm would just pivot. There's no resistance to a bending moment in that direction. So if it didn't break in flight, then it was broken on the ground by some other event with a shock load applying a vertical force downwards on the end of that lever, and it was the weight of the lever and the weight of the push rods downwards that snapped it. So as before, I'm waiting for the parts to arrive to me so I can look at the fracture details. I am seeking details from Shemp Hirth on the lever arm materials. If I am able to, I can find some of the material specifications, like the fracture toughness. I will have a go at calculating just what kind of force was required to snap that arm for a crack of that size in that thickness of metal, and see if that looks like a fair and reasonable kind of number or not. And then we'll have a look at doing a risk assessment for potentially similar defects and other nimbuses, as it nimbi. If anyone's got a good name for a plural of nimbus, please let me know. Another control event, a DG1000S, again very fresh, in the last week or so. On approach, pilot applied full air brake and the air brake jammed fully open. After jiggling the air brake system, the air brake was successfully unjammed and operated normally again. The landing was successfully safe. The starboard lower air brake blade, the outboard end of the bottom edge on this aircraft, extends above the lip of the air brake. The blade had bent backwards with the airflow and was catching on the lip of the air brake box. The port lower air brake blade edge is below the lip of the air brake box, so it wasn't going to catch. The maintenance manual states that the air brake extension height depends on the wheel brake adjustment, but because there is a mismatch between the extension on the port and starboard sides, I suspect it's more a difference in rigging between the two sides of the air brakes, and that the starboard is extending out further than the port. There is an air brake stop in place, but at the moment looks like it only comes into contact if the air brake was completely disconnected. And the interesting thing is this was a second event. This very defect was picked up previously on this aeroplane during maintenance, and it was identified as a possible problem, but it wasn't rectified and the aircraft was allowed to go back into service. This could have been quite nasty. Full air brakes on approach could see you, someone putting the aircraft through a fence with some pretty disastrous consequences. Onto defects. Again, defects are what I'm classifying as not found in operation but found during maintenance. A Speed Aster 2, this one's from the buyer beware file. The aircraft was sold to a new owner and the next annual inspection was carried out by the new owner. During the search of the logbook, it was found that the winglets were fitted in 2006, but there was no approval to fit the winglets found. So for the time being, the original wingtips were fitted and the winglets removed until there's some sort of approval in place. A small piece of straight wire was found inside the fuselage near the belly release. It was later found to be one leg of the release spring. You can see there's a fair amount of corrosion on the mounting plates for the belly release, and the release could only be opened to approximately 2/3 of the movement. It was just enough to allow the rings to pass out of the release cage. The release cable had a thimble and swage fitted, and with the thimble fitted around the bolt you can see on the release, and the swage was fouling on the pulley prior to the release achieving full opening. According to the GROB data, the release cable should go through the hole inside that bolt and then be terminated with a nickel press swage to allow full movement of the release action. Again, from the owner beware file, a Discus 2B aircraft was again sold to a new owner, and on the next inspection they opened up the instrument panel and saw quite a sight. Very poor standard of wiring. You can see all sorts of interesting features there, and potentially the risk of a short and an electrical fire. A Pilatus B4, incorrect assembly of the rudder mounts. During the annual inspection, it was found that the upper and lower bolts were swapped around. Now these bolts are different lengths. One bolt had a very large number of threads showing, and the other bolt had very little threads showing, so the bolts had been swapped around at the previous annual inspection. Where you do find that, it's always good to put the bolts in separate little baggies or separate little containers and marked appropriately so you control the parts and where they are. DG1000S, a bolt in the undercarriage spring was found to have failed. I don't have any further information on that one at the moment. A DG1001, an interesting one, the brass bush in the canopy frame for the locking pin had come adrift. During operation of opening and closing the canopy, that bush can slide forwards and will partially enter the taper of the hole of the stud mounted to the fuselage. With the bush in that taper of the hole, you can't open the canopy. So there was several attempts there to fix that bushing back into place. More recently, a DG1000S, during an annual inspection, there was widespread corrosion found under the cockpit floor. The water ballast bags had been leaking slowly and dripping into the fuselage. It was running down the inside of the fuselage to a low point on the floor where there was not a drain hole. This water had built up for several weeks, and the control circuitry in there had been left sitting in a puddle of water. Also, there was at least one loss of bladder control event at about the same time that had contaminated the area. So the end result was, you can see the push rod there and the state that was in during the annual inspection. It's a bit of an oversight that there wasn't a drain hole there, but also a bit of an oversight that there had been an amount of contaminating fluid deposited into the aircraft, and they had not gone and cleaned up the mess sufficiently well and pulled the seat up to see if any had drained under the seat into the floor of the aeroplane. An EB29R, this was the first of type survey. There were unshielded electrical terminals on the starter solenoid circuit, so you can see the before and after. The before is on the upper circuit, upper photo. The after is lower. Certainly a risk of short circuit there or arcing across. And the starboard static tubing had been kinked. During manufacture of the airplane, the tubing was too long and had been forced into the airplane to the point where it was bending back on itself and kinked. The tubing was shortened and straightened, and it was fine after that. Also, a JS3 during the annual inspection on the port outer flaperon was found to be debonding at the trailing edge over a distance of about 8 centimetres. That resulted in quite a loss of torsional stiffness, and the outer flaperon there would not have been responding particularly well to control inputs. Reduced control authority as a result. STEMI S10VT, the maintainers were doing a compression leak test. They had a compression leak on one cylinder. They removed the head and found corroded exhaust valves. Whilst they were inspecting the heads, they found some strange brown material was blocking part of the coolant channel on the number 2 cylinder head. This was completely independent and not affected by the compression leak. The coolant system was flushed and there was more material found in the radiator. This was eventually traced to being excess sealant that had been used in construction of the radiator. The sealant had been squeezed out during construction, and coolant flow had then broken bits off, and this had moved through the coolant system, was starting to block up some of the smaller ports, which could have resulted in a significant engine overheat event. And lastly, an ASK-21, during rigging of the tailplane, a foreign object was seen at the bottom of the tailplane, bottom of the fin. This is the bottom of the fuselage junction with the vertical fin. The object was a nozzle from the end of a blower that was used to clean the fuselage of dust during the annual inspection. It had come off the blower and been blown down the length of the fuselage all the way to the vertical fin. So top marks for the people who saw that one and found it. It wouldn't have been an easy spot looking down the tail fin. I'm not sure how many people would habitually look down the tail fin prior to rigging the tailplane. And that's it from me. That's not a complete list of all the defects or incidents in the last 12 months, but is a reasonable majority. I was trying to keep it relatively short. Do we have any questions? Please stick your hand up if you've got questions. All right, let's try that. Roger, if you want to unmute yourself, have a go.
Okay, it looks interesting to see the matter with the DG1000 undercarriage components with the spring element, and you showed the example where the bolt had failed on one side of the 2 bolts. Has anyone actually done maintenance on that sliding joint, that telescopic joint? Because I think it's something we tend to overlook, and there must come to be a time when you actually need to overhaul that sliding joint. And if you do overhaul it, do you lubricate it and then attract dust and crap, which creates a grinding paste to grind the bush away, or do you leave it dry? There's nothing in the manuals to assist, so someone's got some experience out there in the real world, I'd really be appreciative. Thanks.
Right. Have you tried seeking advice from DG?
Not yet. It's just one of the things in the back of my mind. I should get off my backside and give it a go. And then if they do respond usefully, to promulgate the information.
Right. Well, we have the AN system for promulgating that kind of useful information.
Yeah.
We're trying to reinvigorate the AN system at the moment and update that accordingly. So we have the airworthiness alerts, which will come out when we find interesting things that are not worthy of an AD, but are worthy of people of the type being aware of. And once they have aged a little bit, nominally 12, 18, maybe 24 months, they'll be cancelled and rolled into the AN system. Thanks, Roger. Anybody else? Well, that's looking all quiet on the Western Front. Well, thank you, everybody. That's a little bit shorter than I expected. I was looking at getting through that in about 50 minutes, and I've made it in about 40. So hopefully that was of use to people. Have a good night, and I will see you all next time.